After you have placed all the components on the board that you are going to design, the next thing that you have to do is to set the environment up so that it follows the specifications and the limitations which the fabrication house imposes. So now is the time when you navigate to the website of the particular PCB fabricator you are going to use and look up their capabilities and see what they say about minimum design requirements. So let's, for example, assume that we are going to go with the Bay Area circuits, which you guys are familiar with. So if I open up the Bay Area circuits PCB design guidelines, then I see that there are a lot of different things which are mentioned here. Now the trick is to navigate through this list and find out the things which are important for you. So for example, one of the things which is very important is this trace or space recommendation. What this means is that what needs to be the minimum thickness of your wires and what needs to be the minimum spacing between two wires that you would draw on the board. So Bay Area says that if you are using half-ounce copper, then it has to be a minimum of 3 mils. And if you are using 1 ounce copper, we are going to have to use at least 5 mils. So we will go with the 1 ounce copper choice, which is more often than not the normal choice that people go with by default. And so 5 mils. So note it down somewhere that you need to have 5 mils spacing between wires. So let me use that notepad which I had used earlier. And let me see if I can have the two of them side by side so that we can write these things down. So the specifications are trace or space is minimum of 5 mils. Okay, then what else do they have? Then they have minimum pad size over finished hole size is 15 mils. Now this is something that you need to take care of while creating the components. And we had taken care of that anyway, so this is something that is related with the components, so that part is done, so we don't need to worry about that. Minimum clearance of finished hole to copper is 10 mils, which means that between a hole that is a pad and a trace, separation needs to be at least 10 mils. Okay, then copper to edge of board, so edge of board clearance needs to be at least 10 mils, and since we are working with 2-layer board, we are just concerned about the outer layers. And plated slots should have a pad size of 15 mils or higher. We do not have any plated slots, so we don't need to worry about that now. Drill size again is something that we had to bother about when we were creating the components. So minimum finished hole size is 10 mils, and 10 mils is well below the sizes that we have used, so we should be fine. Then copper plating. Average plating is not something we have to worry about because these are all related with creating the components. Material. Now note this, the material is that they are going to use is FR4, and then standard thickness is 0.62 inches, or standard thickness is 62 mils. Okay, and then the finish is HASL. This is not something you have to worry about now. Solder mask web, which is the separation between two pads, and I'll show later on in that video where we discuss about PCB terminology what a solder mask web is. Then silk screen feature size, this is very small, but we have used higher than this, so that is fine while creating components. The rest, routing and tab routing, etc., these are things which we are not necessarily concerned about right now. So these are the things that we have to take care of. Now since we are using millimeters, if we convert these into millimeters, then 5 mils converts into 0.127 millimeters. Then 10 mils convert to 0.254 millimeters. Edge of board clearance is the same thing. The material is FR4, and then this 62 mils, if you see, it's close to about 1.6 millimeter separation. Now, with those information in mind, what we will first do in our PCB environment is to set up something which is called a cross section. This is related with the thickness of the board, which we saw that it mentions that the material used is FR4 and the standard thickness is at least 62 mils, which is 1.6 millimeter. So when we open the cross section up, then we see that it is by default a two-layer one, where the of course, I mean, above and below the board, if you are holding it, the surface would be air. Then there would be top copper, bottom copper, and there would be dielectric in between. It's already chosen to be FR4, so there is nothing to change there. You can leave it as is. We are using copper material, so that is fine as well. Change the material here to 1 ounce copper, and then change the thickness here. For two-layer boards in general, what you can use is a 0.07 millimeter thickness for the top and the bottom, and then for the FR4 dielectric in between, you can choose a thickness of 1.5, which takes it to 1.64 millimeter. That is well above the 1.6 millimeter standard thickness requirement. The rest you do not have to touch. After this, you just do an apply, and once it is applied, you do an OK. Right? Now, whatever board you are going to design now, here is now going to take those options from in there, and hence that is set. In the next video, we will see how to set the constraint manager up so that we can also take care of things like the trace and spacing, everything automatically, and not have to think about it from one wire to the other.